Okay, so the next type of special product is called a perfect square trinomial. So we want to think again the word perfect square. Remember, those are our numbers like 4, 9, 16, 25, and so on. And we're looking at both the first term and the last term to be those perfect squares. And then both factored terms are the same. So what it means by factored terms would be that it would be something like x plus 2 would be the first one, and then you would get x plus 2 again. So since they're the same, we would then just simplify that by writing x plus 2 in parentheses squared. Because remember, this little squared means that there are 2 of them. Okay, so let's take a look at the first example. And we have x squared minus 16x plus 64. So first term is a perfect square, right? Because it's just x squared. So that's good. We know that's x and x. So we're good there. And 64 is a perfect square. We know that this is 8 times 8. Okay? So once we figure that out, you identify that, which I probably should have wrote. I'll write this here as, x times x. So now, since they're the exact same, you know that you're going to have an x and an 8 and an x and an 8. Now, the only difference is we need to figure out, is it going to be plus in both or is it going to be subtraction in both? So how you do that is that we know when we combine 8 and 8, so like the factors of 64 are 8 and 8, but they're technically also negative 8 and negative 8. So which ones, when you combine, are going to give you this middle term of negative 16? Well, if I combine 8 plus 8, remember I get 16. Negative 8 plus negative 8 gives me that negative 16. So this is the one that I'm going to be using. So then that means this is going to be x minus 8 and x minus 8. Since they're the same, then we simplify by writing x minus 8 squared. And then you're done. Okay, so I showed a lot of work there that isn't necessary. Like a lot of this can be done in your head, but I'm just kind of writing everything out so that you can see. So for the next one, we know we have x squared. That's a perfect square, x times x. And then 121, we know we either have 11 and 11 or negative 11 and negative 11. So which one of these is going to combine to give us positive 22x? Well, then that's going to be 11 and 11. So I'm going to write this as x plus 11 times x plus 11. But the whole point of this is that they're the same, so that I can write this as x plus 11 squared. Okay, so when it looks like A and B, when you just have that A value is equal to 1, it's simple because it's just x and x. But when you look at C, now we have our last term is fine. This is 2 times 2. But what's changed here is 9 we need to break down as 3 times 3. And y to the 4th breaks down as y squared and y squared. Okay, so you've now figured out your parts for A and B. So 3y and 2 and 3y squared. 3y squared and 2. And then it's just a matter of signs. So since we have on the inside that's a negative, then we're going to have to deal with minus and minus. So 3y squared minus 2 squared. Oops, sorry. I boxed it up before I should have. Wasn't there a... There we go. 3y squared minus 2 squared. Okay. All right, so jumping down to D. So look at your first term, x and x, good. 25 can be 5 and 5. How do I know if it's going to be 5 and 5 or negative 5 and negative 5? We look at the middle. It's positive, so it's going to be positive. We know this is x plus 5 times x plus 5. They're the same, so x plus 5 squared. Okay. Now looking at E, let's take a look at the first term. 16 can be broken down as 4 and 4. X squared can be x and x. 9 can be 3 and 3. So we have 4x, the middle term subtraction, so it's minus 3, and 4x minus 3. And then you can always double check that this does actually work. So by doing that, you're making sure, okay, we have, let me change colors here. 4x times 3 is 12x. 4x times 3 is 12x. 12x and 12x can be combined to negative 24 when we're dealing with the negatives, of course. So that works. So our final answer is 4x minus 3 squared. Okay. All right. Let's jump on down. Well, I guess I'll just keep going. This becomes 2m and 2m. This becomes 3 and 3. It is positive 3 and positive 3 because our inside is positive. And so again, that checking, 2m times 3 is 6m. 2m times 3 is 6m. 6m plus 6m does give me that 12m that I have in my middle term there. So 2m plus 3 squared. All right, last two down here. Now, sometimes you're going to run into and you're going to see, okay, well, wait a minute, 2 is not a perfect square, 32 is not a perfect square. So if that doesn't work, remember, I said this in the last section, and this is all the way back from section 1. You should always check for a GCF. Okay, so everything here is divisible by 2. It just makes things simpler because now by factoring out the 2, I'm left with x squared plus 8x plus 16. Okay, so x squared, I'm good, x and x. 16, I'm good, 4 and 4. And I know I'm dealing with a positive because of my inside. And I know that x times 4 is 4x. X times 4 is 4x. Combine those to get 8x, and that's my middle term. So I know that I factor that correctly. So I have my 2 on the outside. And since they're the same, we're doing these perfect trinomials. So I have x plus 4 squared. Okay, so same idea with the next one. 3 is not a perfect square, neither is 12, so I'm going to divide everything by the GCF of 3. GCF goes out in front. X squared minus 4x plus 4. Okay, so now x squared, x times x, 4 is 2 times 2. So that's good. Now I need to think 2 times 2 or negative 2 and negative 2. Well, my middle term is negative, so I'm going to be dealing with this one. So I have 3 on the outside and x minus 2 squared. Okay, so that's for your perfect square trinomials. So always check for GCF and check and see if your first and last term are those perfect squares and that they can combine to give you the sum of the middle term.